Well, I had to clear out some of my memory. Anyway, I'm back. We wanted to find the arc length of this function here, r equals 1 plus cosine theta, on the interval from 0 to pi over 2. Again, maybe by repetition this stuff will become second nature to you, but again, all we're looking for is the arc length from here, 0, there's our theta 1, and remember our function hits the y-axis, or hits 0, 1 on the y-axis, I guess you could say. The point would be 1 comma pi over 2, so theta 2 is pi over 2, theta 1 is 0, and so the integral, the arc length would be the integral from 0 to pi over 2, and we're going to use the formula. So we have r squared plus dr d theta squared d theta. Okay, well, all you have to do is define your y1 as 1 plus cosine theta, and we're going to integrate the r3 because this guy is our r3. Okay, and if that's our r3, this becomes just a calculator issue here. Math 9, 0 to pi over 2. Again, the y variable, be careful here because you're not going to do function mode, you're going to go down to polar mode, enter, and it's r3, okay, d theta now, and you hit enter. Okay, so the length of the arc, the length of the curve from 0 to pi over 2 is 2.828. Okay, so there's our length of our arc. Now, I wanted to show you something that was kind of cool. Why don't you find the length of the arc from pi over 2 all the way to pi. So it would be this arc right here. Okay, so on the interval from, let's see if we can fit that all in here. On the interval from, can I get that in there? Yeah. On the interval from pi over 2 to pi, okay, the integral would be, now, if you want to pause the video and try this on your own, that'd be great. I'm going to go ahead and show the solution now. I'm going to hit second entry. That's the enter button. Now I get to go ahead and change my limits of integration. So I'm going to change the 0 to a pi over 2. Okay, and I'm going to change the pi over 2. I'm going to delete that. Delete, delete. I'm going to change that to not 0, pi. So pi over 2 to pi of the same function. And if I change that from 0 to pi, I get 1.172. 1.172. Now, here's the deal. I want to illustrate the symmetry of this function. Okay, the function is symmetric. Remember, with cosine, the functions are symmetric with respect to the x-axis. Okay, so if that's the case, you should be able to get the same, if it is the case, and since it is the case, the length of the arc of this graph here, length of the curve from pi over 2 to pi, should be the same as the length of the arc from pi to 3 pi over 2. So this is 3 pi over 2. This right here is pi. You get an angle of pi 0. Okay, so let's do this again. Second entry. We're going to go from pi, delete, delete, okay, to 3 pi, insert 3 pi divided by 2. Okay, and we're going to use the same thing. We're going to get the same exact value. Okay, now you might estimate that, hey, if I get the same value there, then I should get the same value from 3 pi over 2 to 2 pi. So go ahead and do that. So pi to 3 pi over 2, we get 1.172. And then on the interval from 3 pi over 2 to 2 pi, we should also get 2.828. So go ahead and confirm that. Second entry. And we're going to go from 3 pi over 2, let's do that first. 3 pi divided by 2. And we're going to go all the way to 2 pi, and we can delete these guys, to 2 pi. So double check your numbers and enter, and we should get 2.828, and we did, so that checks out. So I just wanted to illustrate the symmetry of this graph. When we did area, one thing you might have noticed that I didn't mention before, if you wanted to find the area of this region here, the whole thing, can you think of a different way that you can actually show that? Because the last time we did the area of that region, we went from 0 to 2 pi, and we got 4.712. So just to reiterate, if we wanted to find the area of that, we could double the integral from 0 to pi. And that would be the 1/2 r squared, so 1 plus cosine theta squared d theta. So we can double the integral from 0 to pi because we know that this function here, the graph of the function, is symmetrical with respect to the x-axis. And so that would be another way. In fact, if you have to do this by hand, this would be much easier than having to go from 0 to, well, I shouldn't say much easier, but it is easier, go from 0 to pi. Instead of going from 0 to 2 pi. You just have to remember to multiply that by 2. So that's it, and go ahead and do the problems in the book, and I will see you next class.